The shape of the container is a funnel-shaped glass. We chose 1 cup as our cup size based on how many could fit into the container. Based on the data as seen on the graph, um, the sand, the height of the sand increased quickly at first and then increased slowly. The shape of the container is a circular shaped glass. The cup size used was 1/4 cup, and we chose this based on the size of the container. Based on the data seen in the graph, the rate at which the sand was filling was constantly increasing at a slow rate and then began increasing at a quicker rate. The bottle shape that we use is more tall and it's very narrow at the bottom. The cup size we use is 1 tablespoon. We chose a certain cup size based on the shape of the vase used. Since we needed 10 scoops to fit, we chose a small scoop size. As we were filling the vase, based on the data in the graph, the rate at which the sand was filling was increasing constantly at a fast rate. Towards the end of the graph, we observed a difference in the rate, changing from a quick rate to a slow and constant rate. So this shape of the bottle is a ink bottle shape, and we chose a 2/3 cup as the scoop size. We chose this certain cup size based on the shape of the vase we chose to use. Since we needed 10 scoops to fit, we chose this particular scoop size. As we were filling the vase, based on the data in the graph, the rate at which the sand was filling was increasing very quickly, constantly, and we also observed the sand constantly increasing at a slower rate towards the end of the graph. For the ink bottle, it starts and ends with a constant width, meaning that the graph should begin and end with a linear function. Since the bottom part of the bottle is wider than the top where the funnel is, that means that it'll be less steep. It'll be less steep for the function. Also, where the ink bottle starts to narrow in, that shows a non-linear or constant part of the graph. So the ink bottle corresponds with graph G. For the bucket, it starts to increase quickly at first, but as it goes on, it starts to increase a little bit slower. So the bucket corresponds with graph A. For the conical flask, it increases quickly at first, and then as it continues on, the height increases a little bit slower, and that can be seen corresponding with graph D. The base corresponds with graph E because it starts out less steep, and then as it continues, gets steeper, and then ends off less steep again. The plugged funnel starts with a constant rate of change because of the bottom part, which has a constant width. As you continue, the graph starts to become steeper because the funnel starts to narrow in and the sand fills it more quickly. Then the graph ends off with a decreasing rate of change. This can be seen in graph B. For the evaporating flask, the change in height for the increase in volume will go from fast to slow to fast and end at a constant. The constant rate of change, or the linear segment that will be seen on the graph, shows how the top of the bottle fills quickly. And so the evaporating flask corresponds with graph I. Graph H, it corresponds with this vase, and we drew the shape of this vase like this because the graph shows how it goes slowly and then quickly and slowly and quickly. So this part corresponds with this part, and this part corresponds with this one. So that's why we drew it like this. So this is graph C, and so based on what the graph is showing us, it started with a fast rate of change, so that's why we drew it this particular shape. And then this part of the graph, which is a slow rate of change, we drew it this particular shape so that it can correspond with the graph. So this is graph F, and so this graph, based on what it's telling us, it corresponds with the shape that we drew because the graph tells us that at first it's a slow, constant rate of change, so that's why we drew it this shape. And then towards the end of the graph, it's a fast, constant rate of change, and this was a simple shape to draw since it's like the opposite of graph C.